Okay, good morning. So, we're gonna have our next topic about Gauss's Law. Meron pa din tong kinalaman guys sa electric flux po. So, what we're going to do today is introduce Gauss's Law to you. So, bago yun, I want you to look at this example first. So, meron akong point charge, 3.0 microcoulomb surrounded by an imaginary sphere of radius r, which is 0.20 meters centered on the charge. Find the resulting electric flux through the sphere. So, gawin muna natin siya ng konting drawing, no? So, sabi, meron daw akong charge. Yung charge ko, sabihin natin yung charge na yun is charge Q. And that charge Q is a positive charge, no? And sabi, kuha ka ng 0.2 meters from this. Sabihin natin, from this charge to this point outside is 0.2 meters. Tapos, tsaka kayo gumawa ng sphere. Sphere. Yan. Ay, okay. Isipin nyo lang perfect yan. Tapos, etong sphere na to, sphere is a 3D, para siyang bola, no? So, sabi, what would be the, find the resulting electric flux through the sphere. So, etong ginawa nating sphere na to is, what we call, somehow, hindi siya totoo. Imaginary sphere siya. So, from this point to this point, we have R, which is 0.20 meters. Okay? Bukod doon, from this point hanggang this point, diba R is equal to 0.20 meters pa din siya. And all over the surface of the sphere, R would always be equal to 0.20 meters. In short, meron tayong tinatawag na symmetry. Tama? So, let's have the direction of our electric field. Di ba, remember when we talk about a positive electric charge, di ba yung electric field niya would possibly and will always go outward. So, kung ang electric field niya is outward, then our flux is also outward. Meaning, yung electric field ko can go this way, it can go this way, it can go this way, this way, this way, and this way. Tama? So, anong napapansin nyo? If you remember our topic about the charges, yung parang ine-emit nilang electric field is always radially either outward or inward. So, inward siya kung negative tong nasa loob. Ngayon, gusto kong pansinin nyo itong mga points na to. Lahat ng points sa surface ng aking sphere, yan, yung point na yan, yung electric field ko at that point are pare-pareho. Okay? So, pare-pareho yung electric field. Electric field ko dito, the same here, and the same here, and all other na nilalabasan nung aking electric field or aking electric flux. So, now, I want you to also to look at this figure and remember our topic about the small parts of area. So, sabihin natin, kunwari, kumuha ko dito ng isang part ng area ko. Okay, isang part. Yung surface ko, parang nag-pinch ako ng konti, ganyan. Okay? So, yung area na to, di ba? Remember, our area, yung direction ng area natin is always going what? Outward. So, ibig sabihin, lagi siyang perpendicular to the surface. Ito yun, lagi siyang perpendicular to the surface. 90 degrees for my surface. And the area is always going outward. Meaning guys, kung ang area ko is going outward and my electric field is also going outward, sabihin natin, kuha tayo ng area ko dito. 'Di ba? Anong papansin niyo sa kanila? Yung area ko at yung electric field ko is somehow parallel to each other. Ayan. Okay? Meaning, yung data natin kung parallel siya is equal to 0 degrees. Remember? So now, yan yung magandang itsura ng sphere. Okay? So I want you to take note of this. Yung surface natin, hindi siya flat surface. Kasi nga, sphere yun eh. Bola. And the electric field is not uniform. Ano ibig sabihin ng not uniform? Pag tinignan mo mismo yung drawing natin, yung distance ko between these electric fields and in this area at yung distance ko ng electric field from this area is magkaiba. So, hindi uniform yung electric field natin. And because the sphere is centered on the point charge at any point on the spherical surface, E is directed out of the sphere perpendicular to the surface. So, kagaya ng area natin, yung electric field natin is also perpendicular to the surface. Diba? Okay. Ano pa? So, let's somehow get this area. Diba remember, if I want to calculate for the electric flux, lagyan ko to ng color block. So, if I want to calculate for the electric flux, diba, it must be E dot E dot A. Okay, electric field dot A. Or E A cosine theta. So, hindi ko na siya i-derive talaga, guys. Pero, we know that our theta, the angle between my electric field and my area is 0 degrees. So, kung ilalagay ko dito, E A cosine 0, cosine 0 is equal to 1. So, ang matitira na lang sa akin is E times A. Pero papansin mo, wala ka naman given na electric field. Ang given mo is charge, which is positive 3.0 microcoulomb. And may R ka na 0.20 meters. So, remember our electric field, guys. Di ba, ang formula ng electric field natin is K times Q all over R squared. Tama? And itong K na to, if you will also remember, this is also equal to 1 over 4 pi epsilon naught, or the permittivity of free space. So, ito yung K natin, itong part na yan. Okay? And then, lagay natin si Q over R squared. So, times Q over R squared. Now, tingnan mo mabuti. Pwede kong ilagay to, itong E na to, E is equal to Q over 4 pi epsilon naught R squared dito, sa E ko dito. Okay? So, lagay ko Q over 4 pi epsilon naught R squared times yung area ko. Now, itong area ko, guys, yung area na to, is meron din siyang, anong area to? Area, of course, ng aking surface area ng aking sphere. Bakit surface area? Kasi, ang nilabasan niya is the surface of the sphere. So, let's have this area ng surface area ng aking sphere. So, if tanda mo, yung lesson mo dati sa geometry, that would be 4 pi r squared. Okay? So, itong 4 pi r squared natin, i-substitute natin siya dito. So, lagay natin Q over 4 pi epsilon naught r squared times, yung area ko is 4 pi r squared. Looking at this example, magiging masaya ka na kasi pwede ko palang i-cancel si 4 pi. Tama? Pwede ko na i-cancel si r squared. At ang matitira ko lang is walang iba kundi walang iba kundi itong flux ko daw would be equal to Q all over epsilon. Okay? So, sa isang point charge surrounded by an imaginary sphere, we will have, our electric flux would be Q, or the charge, all over epsilon naught. So, kung i-solve natin yan, guys, lagay natin electric flux is equal to Q over epsilon naught. Substitute po natin yung mga values natin. Q is equal to 3.0, positive 3.0 times 10 raised to negative 6 coulomb. Okay? All over epsilon naught, may value po yan, 8.85 times 10 raised to 12 coulomb squared per Newton meter squared. Okay, so kung may cancellation, cancel si C. And then, my electric flux would be equal to, sige, nandito na po yung sagot actually. Ayan, 3.4 times 10 raised to 5 Newton meter squared per coulomb. So, ito po yung final answer natin. Okay? Ngayon, yung nakuha natin kanina, remember, itong part na to, guys. That's actually the generalization of our Gauss's law. So, yan po yung Gauss's law formula. Ang ibig sabihin yan, yung total charge ko in an enclosed surface, di ba, tada yung charge natin, naka-enclose siya sa isang spherical surface na imaginary, divided by my epsilon naught, that would be my electric flux in that closed surface. So, that is the Gauss's law formula. Okay? Now, yeah. So, may nakalagay dito, guys, na there we found that the flux of electric field was independent of the size of the surface. Kasi, di ba, tingnan mong mabuti yung formula mo. You have your electric flux equals to Q all over epsilon naught. Wala dyang R. Wala dyan yung, nasan yung R mo dyan? Di ba? Wala kang radius nung mismong spherical surface. Bakit? Kasi, independent po yung size ng surface mo dun sa pagkuha mo ng electric flux mo po. So, the same result holds true for a spherical surface. Kahit doblehin pa natin yung laki ng spherical surface natin, same pa rin yung makukuha nating electric flux. So, indeed, the flux through any surface enclosing a single point charge is independent of the shape or size of the surface, as we'll soon see. Okay? So, yan po yung pinakang equation ng Gauss's law natin. Diyan po, parang iikot lahat-lahat ng bagay. But syempre, nandun pa rin kay electric flux yung concept niya. Diba? Okay. So, Gauss's law, it was formulated by Carl Friedrich Gauss, one of the greatest mathematicians of all time. So, nagpapakita to ng relationship between the field at all points, kagaya nakita natin kanina, on the surface, and the total charge enclosed. So, lagi niya titingnan itong enclosed. Si Gauss Law, gusto niya yung enclosed surface and ang tawag dito, yung field, yung relationship between the field and the enclosed surface, and the total charge in the enclosed surface. So, generally, it states that the net electric flux through a closed surface is directly proportional to the net charge inside that surface. So, net charge is what? Net charge is the total charge in that surface. Okay? So, kanina, di ba, kung tandaan nyo yung drawing natin kanina, meron tayong charge sa loob. Tapos, nag-drawing tayo ng imaginary sphere. Okay, imaginary sphere. Para i-enclose itong charge natin. Ngayon, itong imaginary sphere na to, alam natin na yung electric field na lumalabas sa kanya is like equal. Equal yung electric field. It's constant sa part na to. Diba? Ngayon, ang tawag dito sa ginawa nating surface na to, imaginary surface na to, is what we call Gaussian surface. Okay? And yung Gaussian surface natin, guys, ito often is imaginary siya. Pero minsan is pwede din siyang maging totoong surface. Okay? So, sabi dito, a closed surface in three-dimensional space such that the flux of a vector field is calculated. So, ginagamit natin ng Gaussian surface to really find the what we call the flux, the electric flux of a vector field. So, bigyan natin ng example. So, meron ako dito medyo weird looking na charges, na space na, okay, enclosed surface na may iba't ibang charges sa loob. So, i-apply natin yung natutunan natin dito kay Gauss's law. Sabi dyan, guys, if I want to find the electric flux at each surface na nakabilog, so for example, sa surface 1, I want to find my electric flux there, kay surface 2, and hanggang kay surface 5. So, ano yung magiging sign ng flux ko? Or ano yung magiging result ng flux ko? So, tingnan natin mabuti. Okay. Tingnan nyo mabuti, guys, itong surface 1. Highlighter. Sabihin natin ito yung surface 1 ko. Okay? Sa surface 1 ko is walang naka-enclose na charge. So, ibig sabihin po, kung gagawa po ako ng formula ko, my flux at surface 1 would be, syempre dapat total enclosed charge kay surface 1 and all over permittivity of free space. Since walang total charge dyan, that would be 0 over epsilon naught. Meaning, yung electric flux ko at my surface 1 would be 0. Okay, so tingnan niyo po yan. Punta tayo kay surface 2. So, tingnan niyo naman po mabuti si surface 2. So, itong surface 2. Ay, sorry po. Okay, surface 2, highlighter. Ayan. So, surface 2, ilang charge yung naka-enclose sa kanya? Naka-enclose sa kanya si -7 microcoulomb na charge and gawin natin. Meron dito. Okay, hindi ko po makita. Ayan. So, nakalagay kay surface 2 si -7.0 microcoulomb na charge, si +5.0 microcoulomb na charge, and si 9.0 microcoulomb na charge. Okay? So, what I'm going to do here, guys, is to get the total charge or net charge ko dun sa surface 2 ko. Okay? So, paano ko gagawin yan? I-add mo lang lahat to. So, -7 plus 5 is -2 plus 9, meaning I have a net charge of positive 7. Tama diba? Positive 7.0 microcoulomb. Okay? So, yan yung ilalagay ko dun sa pagkuha ko ng electric flux ko at surface 2. So, Q and goes kay surface 2 all over epsilon. So, I'll put 7 times 10 raised to -6 coulomb all over my 8.85 times 10 raised to 12 coulomb squared per Newton meter squared. Then, cancel. Okay? So, yung makukuha niyong sagot dyan. So, yan naman po yung electric flux ko inside my surface 2. Okay? So, as we go on and we go on, tingnan mo naman itong, for example, si surface 3. So, kay surface 3 naman po, highlight ko po siya. Sinong included? Okay? Included po sa kanya si na 9, positive 9. Sorry po. Lagay natin dito. Okay, block. So, included sa kanya si positive 9.0 microcoulomb. Included din sa kanya si positive 1 microcoulomb. Included din sa kanya si negative 10 microcoulomb. Then, you add this, guys. So, pag in-add niya, negative 10 plus 1 is negative 9 plus 9. So, 0 naman siya. 0 microcoulomb. Ibig sabihin, kung 0 yung enclosed ko na surface, and then, my electric flux, so, 0 po yung charge or yung net charge ko, then my enclosed flux would also be equal to 0. Diba? So, enclosed flux. So, wala akong flux kay surface 3. And so on. So, pwede nyo po yan gawin kay surface 4, kay surface 5, so on po. Okay. So, yung susunod po natin mga example would be on my next video. But, let's see here. Sabi dito sa Gauss Law, kapag daw meron tayong point charge, kagaya nakita natin, ito summary na lang po to, point charge inside a spherical surface. So, lagi tayo guys naghahanap, di ba? Pansin nyo, kumuha ko ng R. So, may point charge ako dito. And then, nag-drawing ako ng imaginary surface ko na sphere. Okay? Para makita ko yung R ko at all sides ay equal. So, if my radius at all sides ay equal, yung electric field na lalabas will have the same magnitude. So, what I'm really trying to do is finding what we call symmetry. Okay? So, pag nakakuha ka na kasi guys ng symmetry o nakagawa ka ng tinatawag na Gaussian surface will actually promote symmetry. So, yung symmetry na to guys, kasi originally our formula for electric flux is equal to electric field. Okay, the integral of electric field multiplied by derivative of A. Okay? So, itong dA na to guys is, yan yung mga small parts dun sa area mo, dun sa surface area mo na gusto mo siyang i-integrate para makancel siya. So, once kasi guys na magkaroon ka na ng symmetry, nawawala na tong integration na to. Okay? At pag nawala yung integration, it will be easier for you to solve. Gaya ng paglalagay ng EA cosine theta. So, dyan kasi, nawala na yung integration mo, di ba? So, yun, that's very important. And bukod dun, magagamit mo na itong tinatawag nating charge density. Wherein, um, magkakaroon ka ng tinatawag na charge distribution in a uniform electric field. So, ito guys, hindi ko muna siya sobrang ita-topic, but I want you to remember all this charge density. Dahil, sabi doon, sabi sa Gauss Law, nagkakaroon tayo ng symmetry kapag ka, gumagamit ka na nakakapag-solve tayo uh, ng electric flux or ng electric field natin in different materials kung meron tayong symmetry. For example, if I have a na linear po na linear na object. Okay, so for example, if I have a charge here na nasa isang linear surface, okay, and meron ako dyang positive, kunwari lahat yan ay positive, positive, positive. Kunwari, uniformly distributed sila. So, ibig sabihin, yung nilalabas nilang electric field will also be uniform. So, gagamitan ko siya ng charge density dito. Okay? Yung charge density kasi will tell you, yung linear charge density will tell you the charge per unit length. Okay, charge per unit length. So, it's coulomb per meter. So, ito naman is, this is called lambda. This is called sigma. So, lambda. Lambda. Ito naman po is sigma. Ito naman, guys, is rho. Okay? So, surface charge density naman is, ito naman yung ginagamit kagaya dun sa atin, kagaya din sa ginawa natin kanina sa mga charges sa charges sa mga sphere. So, dahil yung dinadaanan po ng aking electric field or electric flux would be the surface of my sphere. So, ito namang volume charge density, ginagamit din po siya sa sphere. Okay? Sa linear charge density kasi gumagamit tayo ng tinatawag nating cylinder. Okay, so sa cylinder kasi nagpapakita to na okay, di ba 'pag cylinder ganyan siya, ayan. Okay. Sabihin natin, ito yung from this point to this point, from this point to this point, this point to this point, equal po yung lalabas na electric field diyan. Okay, equal yung electric field. And from this point to this point, pareho lang yung electric field na lalabas yun kasi symmetrical na siya. Okay? Surface charge density, ano pa, volume charge density. Si volume charge density naman, guys, is ginagamit siya sa madalas po sa mga insulators, mga ganyan, sa mga spherical din po na surface ko. Ngayon, itong volume charge density kasi is more on the inside. So, kailangan mo na talaga ng volume nung mismong spherical surface mo. So, yun, cylinder, pag-aaral natin si cylinder, si plane sheet, and also, yan, yung mga spherical surfaces po natin. So that would be all for this video for now, and I hope you watch this carefully and makapagsagot kayo nung pinapasagutan ni ma'am. Okay, thank you.